All right, all this unit circle stuff has been leading up to doing graphs of sine and cosine functions. So this video, I'm just going to go over the basic sine function and cosine function so we can have an idea of what that looks like. Then what you will do on Desmos or your graphing utility of choice is you will look at what happens when we start adding, multiplying, dividing, subtracting things to these functions. How will it affect their graphs? And what patterns do you notice? What conclusions can you draw from that? So let's get the basic functions down first. So I'm going to start with sine of x. So I'm going to write the function f of x equals sine of x. And what's really confusing about this, or I think it's kind of confusing, is we are going to graph this on this graph over here. And we'll talk about the peculiarities of this in a second. But we're going to be using this other graph that has our unit circle on it to generate the values. And so we're going to have different x's and y's going on at the same time. So I'll do my best to make it really clear what's going where. So anyways, let's go ahead and make a table. So the idea is if we take a value of x, which is going to be an angle measured in radians. So if we plug in a radian value for x, y is going to be whatever we get when we do sine of that radian value. So for example, let's start at 0 because that's where the unit circle starts at 0, which is right here on the x-axis. So think of this as a 0 degree angle or a 0 radian angle. Remember, to find the sine, we look at where does this angle hit on the outside of the unit circle, and it hits right here at this 0.10. The sine is always the y value. So right there at that point, the sine of that angle is 0. What I want to do is I just want to get a rough idea of what this graph looks like. So I'm just going to hit the key point. So what I'm going to do, my next angle is going to hit the top of the graph. I want things where I already know something. I don't want to have to like calculate stuff and rationalize denominators and all that. So I'm going to go to pi over 2. Remember, that's a 90 degree angle. That takes us to the top of the graph. And when I'm at pi over 2, my sine, my y value, is 1. All right, now I want to, so I've rotated a fourth of the way. I'm going to rotate halfway. And it's 180 degrees or pi radians. And my y value here is 0. So when I'm at pi, I'm at 0 again. So I got 0, 1, back to 0. If I go again, another quarter turn, that takes me to the bottom of the graph, 270 degrees or 3 pi over 2 radians. My sine, my y value is negative 1. When I complete my rotation, I get back to where I started. That's 2 pi is 1 full rotation. And you'll notice my sine is back to 0. So you notice I have 3 zeros. It keeps coming back to 0. To really get a sense of this, though, I also need to go to the other side of the graph and do my negatives. So let's go on the other direction. And let's do negative pi over 2. So if I do negative pi over 2, what I'm doing is I'm doing a quarter turn, but I'm going in the opposite direction. So where that's going to put me is down here at the bottom, and my sine down here at the bottom, my y value is negative 1. If I do negative pi, that's a half turn clockwise, and it puts me here at same place positive pi does. And my y value, my sine there is 0. And then let's go one more. If I do negative 3 pi over 2, that actually puts me at, that's the same as positive pi over 2. My sine at that point, the y value of the coordinate is 1. So that's what I'm going to get. And you can keep going with this. You kind of see the pattern. Like every other one is a 0. And then the other ones are all alternating between 1 and negative 1. So let's plot this on the graph. And you'll notice this graph here. What I'm going to do is I'm going to make my 1 right here on this second tick mark on the y-axis. And negative 1 down there. So I got 1 and negative 1. So on the y-axis, a lot of times when you're doing trig graphs, you're going to count by ones or one halves, but it's going to be a typical graph where you just count by normal numbers you would normally count by. On the x-axis, though, you'll see it's got these pi's, and what it's doing is it's aligning with your radian measurements. So you have pi over 2, you have pi, you have 3 pi over 2. So the same key values you get on the unit circle. So I'll show you in a second how you can do that on Desmos so that you can have a graph that works really well with these trig functions. So here on my table that I've made, I'm going to start at 0, 0. So I have a point right there at the origin. I'm going to go positive first. So when I go positive pi over 2, I'm up at 1. Then at pi, I'm back at 0. When I get to 3 pi over 2, I'm at negative 1. And when I'm at 2 pi, I'm back at 0. Going the other way, the negative direction, negative pi over 2, I'm at negative 1. Then I'm at 0. Negative 3 pi over 2, I'm up at positive 1. If I were to go to negative 2 pi, that would put me back at 0. So you can see it's bouncing up and down. It's bouncing up to 1, down to negative 1, up to 1, down to negative 1. So when we connect these, what you don't want to do is make a straight line, because that's not what's happening here. When you look at the actual unit circle, you can see as you go around the unit circle, like if you go from 0 to pi over 2, it goes up pretty quickly, and then it starts to level off. So it's not going to be straight lines. It's going to be a smooth curve. So you're going to go up, level off, hit the point, go down all the way to negative 1, level off, come back to 0. And same thing on this side. And if you really wanted to be precise, you could get a lot more values. And I've got to redo that. That's really bad. You could get a lot more values by plugging in other angles. You could plug in like pi over 6 and pi over 4 and stuff like that. But I think for purposes of what we're doing, we just want to have a basic idea of what this looks like, and we can use like a graphing calculator to get more into the specifics. So that's your basic sine of x graph, and it will continue going in both directions, and it will continue this wave pattern forever towards infinity and negative infinity. So let's go ahead now and do cosine, and cosine is going to be very similar because it's based on the same patterns on the unit circle. And let me clean up these scribbles and get a different color. Okay, so let's do f of x equals cosine of x. And this, I think, is even a little more confusing because what you're going to be doing is plugging in a radian value, and that's your x, and then you're going to find its cosine, which will give you y. But the way you find cosine is by looking at the x value of a point. So a little weird, but we'll be all right. Starting at 0 again. Cosine of 0, 0 degree angle or 0 radian angle, puts us right here at this point again. The cosine, of course, is the x value, so it's going to be 1. So when you're at 0, the cosine is 1. When you are at pi over 2, so 90 degrees, pi over 2 radians, the cosine there, the x value of that point where it hits is 0. So the cosine of pi over 2 is 0. The cosine of pi, so now we've gone a full half turn, we're at pi, the cosine here is negative 1. So the cosine of pi is negative 1. 3 pi over 2 takes us to the bottom of the graph. The cosine here is 0 again. And when we go to 2 pi, we're back to where we started. We're all the way around to where the cosine was 1. So you'll see we have the exact same numbers we had for sine. It's just the y's are lining up with different x's. Let's go ahead and go backwards around the circle, go negative and get a few of those. So when you go one turn negative, so negative pi over 2 takes you to the bottom of the graph. Your cosine there is 0. When you go halfway around negative, your cosine is going to be negative 1. And when you go around another quarter turn in the negative direction, that's negative 3 pi over 2, you're going to be up at the top, and the cosine there will be 0. So same pattern as sine, except basically a different starting point. So if you graph this and you start at 0, instead of starting at the origin, you're going to start at 0, 1. And then you're going to go from there. So then when you go to pi over 2, the next one, you're going to be at 0. When you're at pi, you're at negative 1. 3 pi over 2, you come back to 0. 2 pi, you're back to 1. So very similar to the sine function, but it's shifted. And when we go the negative direction, the same thing's going to happen. We're going to hit here at 0 when we get to negative pi over 2. We'll dip down to 1, back up to 0, and then back up to 1. So you'll notice the sine function and the cosine function, exact same shape. They're just, it's basically a translation. It's been shifted. So its position's a little different. That's the only difference. But like I said, we're going to do things to these sine and cosine functions. We're going to add things, multiply them by things, subtract things, divide by things, and see what happens to them and see how that affects their graphs. So with that in mind, I want to show you on Desmos, and I hope this comes up okay. And if we need to, we can go over this a little bit in class on Wednesday too. But I'm going to pull up Desmos, go to the graphing calculator. If I'm going to graph sine of x, my f of x to be proper. And I can see the wave. I can see this sine wave, and it looks a lot like the picture I just showed. But what I don't have is, whoa. I had no idea it would do that. I thought it'd give me decimals. Never mind. This is great. So I don't think I'm going to edit this out. So you can see right there, it tells you it gives you the radians. It tells you where you're at pi over 2 and 3 pi over 2 and negative pi over 2 and all that. So that's very handy. I don't think it used to do that. So great. What I was going to show you, though, is if you want to change your graph so that the x-axis is in radians, what you can do here is, and I'm going to change this, I'll leave it at negative 1010, but I'm going to change my step to pi over 2. And the way you do that, to get pi, on the bottom left-hand corner of the screen, you have this little keyboard picture. And when you pull that up and get rid of this little thing I have here, you'll see there's a pi button. And you click pi, and you see right there, the graph now is, the axis says like negative pi, negative 2 pi, and so forth. And then I'm just going to do divided by 2 to get my pi. So now I'm counting by pi over 2. And then on my y-axis, it's fine when I'm counting by. I just don't want it quite so big. So I'm going to change this. It's at negative 6.1. I'm going to change this to negative 4. And I'm going to change this other one here to positive 4. So you can change your range and your graph to make it fit what you want to do. And let's see, I'm going to count by ones too. So I'm going to go back to my graph settings. And here where it says step for y, I'm going to put a 1. And then it'll count by ones. So if you want to adjust anything on Desmos, just click on this little wrench. And where it says x-axis, y-axis, you can change your range of values. And you can change what it's counting by to represent whatever you need it to represent. So that's just a quick little thing that may be helpful as we start to put some of these on the screen and look at them. So that is graphing sine of x, and for good measure, cosine of x. Here you go.